Uninterrupted data availability is critical for the modern enterprise. Even small outages can have devastating consequences. To ensure business continuity, data must be replicated to multiple, globally distributed locations in real time to provide the highest level of resilience and availability. MinIO active-active multi-site replication enables applications to simultaneously write objects to 2 or more locations with real-time synchronization, a capability not found in traditional SAN and NAS systems. With active-active replication, all data in a cluster is fully replicated between sites, and applications can write data to any location. If you have 2 sites, A and B, an object added to site A will be replicated to site B and vice versa. In the event a site is lost, the persisting sites continue to support the application seamlessly, without downtime or a need to rebuild. Not only are all objects replicated, any mutation to object metadata, such as bucket policies and authentication tokens, are also kept at parity between locations. Unlike the cloud service providers, MinIO allows the source and destination buckets to have the same name across regions. This allows the application to transparently load balance across sites and maintain application persistence if a site becomes unavailable. MinIO supports both synchronous and asynchronous replication. With synchronous replication, MinIO attempts to replicate the object prior to completing the originating operation. This guarantees the application that writes are completed on all the available sites at a possible cost of stale or missing objects on the remote location. For asynchronous replication, which is still near-synchronous, MinIO completes the originating operation before placing the object into a replication queue, which protects application performance from synchronization completion. Let's consider some real-world failure scenarios. For any number of reasons, a site may go down for a short period of time. In this situation, Site A continues uninterrupted, placing unreplicated objects in a queue that are synchronized automatically when Site B comes back online. Another common event occurs when the link between sites fails, known as split brain. With MinIO, applications continue to write to each individual location. When the link is reestablished, all modified objects in each site are automatically replicated to the other location. Further, consider a situation where the same object is being simultaneously modified on both sites. The objects are safely merged across locations via object-level versioning. It is also not unusual for a bottleneck to occur due to a spike in traffic or network degradation. When this happens, objects are maintained in a queue until capacity is available to synchronize. MinIO's asynchronous replication capability is particularly useful in this scenario because the application can continue to write data to all locations uninterrupted and the data will be resynced. In the event of a long-term outage, potentially billions of objects may be out of sync. Each object is marked and remembers its replication status in the object metadata. In this situation, when Site B comes back online, Site A will detect it and automatically initiate a healing process rather than queuing to resynchronize the data. The worst-case scenario is the complete loss of a data center due to a catastrophe. In this situation, when a new site is ready, you can simply reset the synchronization status and restore an entire cluster. This approach also applies to adding additional sites. Mission-critical data availability is paramount, and MinIO is the only object storage delivering multi-site, active-active replication to ensure business continuity for modern enterprises.